Welcome, everyone. My name is Nabile Safdar from Emory in Atlanta. It's my pleasure to kick off this discussion with Tom Valent from Aidoc. The session is titled Future-Proofing Your AI Strategy with an End-to-End Solution. I am particularly excited about this session because I get to pick the brain of someone who I consider one of the smartest people in the industry. And so I'm getting my money's worth by being able to ask him all these questions. And I encourage you all to enter your questions as we go along in chat, or if you're familiar with the Q&A functionality, feel free to use that as well. And we will go ahead and pass your questions along, and we'll go ahead and get started. Before we go into the juicier questions, Tom, one of the questions that I have for you is I'm always fascinated by how people got started along their path, how they joined their company, what kind of training they required. Were there any key figures that helped you, fashion your trajectory to where you are today? I find it useful because I can compare and contrast with my own experience, but then also as we work with younger folks, people who are trying to get into the field, I think it's helpful to hear that background.
Okay, great. So first of all, hi, everybody. Thank you for joining us. And I think Dr. Safdar exaggerated with his introduction, but I'll take it. In terms of our specific story, with us, it was about having the right group of founders in terms of their core skill sets. So one of our technology founders, his specialization was high performance computing, and the other did AI in satellite imaging. And we then found a radiologist, a neuroradiologist who joined us. And basically it began with, first of all, deciding that the goal is to create a startup. So there are many stories for how different companies begin. In our case, it was, we have the right group of people, what should we do now? Radiology obviously made sense because of the background of one of the founders and also a couple others. They were indirectly related to radiology, whether it's a family member or a few courses in the PhD. But it was seeking a problem in healthcare or a space, right? Because this early, you can't even identify a very specific problem. Seeking a space where there could be pain points that can be addressed with technology, and ensuring that the timing is right, in the sense that oftentimes companies enter a space before the technology is ready or the market is ready. So at that point in time, this was about 5.5 years ago. For those that remember, at that point in time, there were a few brand names in AI, but it was all quite new, right? There was Zebra Medical and Arteris and maybe Analytic or a couple others. So and at that point also, many radiologists were quite scared of the situation. It sounded intimidating. AI, it's going to be so amazing and so perfect, and it's going to replace us all. So that was really the early days before the maturity that we're now seeing. And we thought that there is a good alignment of the market is starting to get used to this concept. We don't need to be the first trailblazers in educating everybody. From a technology perspective, cloud computing was already available and not too expensive, and that enabled a much easier implementation and scalability. And deep learning itself was already proven in other spaces outside of radiology. So that's how we began. And then the next step was a lot of product market fit, interviewing a bunch of radiologists. It was very kind of out of the garage startup nature, in the sense that, like, who knows somebody that can get a connection to some radiologist that we can pick his or her brain and ask questions and check different pathways, et cetera. So that's how it all began. This was about 5.5, 6 years ago.
Well, Tom, the next question that I have for you, I think flows right into that. And that's, after you've shared a little bit about yourself and the origin story of how you've gotten into it, tell us a little bit about Aidoc, provide maybe our audience with some background.
Okay, excellent. So that's when kind of we began creating the company. creating a prototype, identifying really the classic kind of pitch to the initial seed investors, right? Like the key slides of what's the market, what's the potential, what's the prototype, etc. We raised money, and then we started developing. And developing at that point was, first of all, the algorithm. So the prototype was obviously very nascent. We took that and improved it. We partnered with a hospital who provided us the de-identified medical imaging to start training an algorithm. We brought on board a few radiologists to help us annotate, developers, etc. So at that point in time, we were a team of, say, 10, 12 people. 90% of them were either clinical or R&D or both. I was a little bit unusual in that I was more of the business guy. I was the only one that was the business guy at that point in time, although we're speaking about 12 people, so kind of everybody did everything. And the first algorithm we developed was intracranial hemorrhage. The thought was there's so many non-contrast head CTs, say 5 to 10% of them have a hemorrhage. Even if one were to consider it somewhat of a straightforward diagnosis for a radiologist, there's just so many that there must be ways we can provide value there, whether it's triaging an outpatient hemorrhage or an inpatient hemorrhage that has a new bleed or a bleed that grew in size, or just having kind of that really accurate detections. Because we do know that there are some, subtle subdural hemorrhages or subarachnoid hemorrhages. If you look at lawsuits, there are various ways where AI can help with hemorrhages. So that was our first algorithm, and it was the one that we got FDA cleared a few years later. Part of that was also learning how to work with the agency, right? How do you get FDA clearance? And at that point in time, there were very few AI products that were FDA cleared. So we got the first one for intracranial hemorrhage, for example. By now, I think there's like 5 or 7 others. So that's what it was like. And then the initial implementations in a few hospitals where we were naive. So back then we basically said, okay, we have this algorithm. We have our server that can route the right images to the right algorithm. This is our algorithms are on the cloud, and de-identify them along the way. And let's just find the DICOMs that are called non-contrast head CT and route them to the cloud, and it will process, and we'll send them back to the PACS or to the worklist, etc. So we were naive. First of all, we didn't realize how every hospital has a different IT stack. Like, we did realize it, but we didn't realize what it means, right? So the different versions of the different PACS systems, some are more open to integration, some are less. And there are hospitals that they don't even have control of the workstation. So there are a lot of limitations of what we could do. That was one part that we had to learn how to solve. And I assume later we'll talk about the ways we've solved it. And the other was just the fact that a large hospital or a health system or teleradiology group to the extreme, they just have a ton of data, and oftentimes there's not one normalized way of identifying a head CT scan. There's a C-spine and head. There's a head CT scan with and without contrast. There's so many different ways that the case could be labeled, and that's on the DICOM, on the study level. When you go into the series level, it's even worse, and things change, and the scanners are replaced, etc. So you can't really rely on a simple kind of rule where you write, you put into the system, forward to me only cases that are called exactly A, B, C, D, because you're gradually going to miss more and more cases that should be processed by your algorithm and aren't. And the important thing about this is, at the end of the day, we are judged by the users. The end users, the radiologists, they don't know what's happening behind the scenes, how the orchestration happens, and who inserted what sort of forwarding rule, and what your DICOM metadata is like, and all that. They don't know, and they shouldn't care. So our burden is to make sure that we process every exam that we should, and obviously, hopefully, have as much value as we can anytime we process it. It doesn't mean we're perfect, but we strive to be as close as we can to that. And in order to make that happen, we need to have a robust system. Because a lot of people talk about the accuracy of AI, but it's not only about the accuracy of AI, it's also, so to speak, the accuracy of the orchestration to feed the algorithms the right exams in a timely manner, the right images, etc., so that you can give your algorithms the opportunity to do the best they can.
Yeah, Tom, a couple of things that you mentioned really resonated with me. We've talked over the last 2 years or so, and gotten to interact with each other a couple of times. And you know that at my institution, I'm working with researchers who are real AI experts, but may not always recognize some of the complexities in the clinical arena. Like you're saying, a sequence name is not a sequence name. It's almost a full-time job to keep all the MR and CT series and sequences consistently named on every modality throughout a large enterprise. So I work with researchers who don't understand that, but I also work quite a bit with either administrators or physicians who may not understand, hey, you've got some of the best researchers around, publishing cutting edge things, getting big grants. Why can't we just take their model and pop it into our environment? After all, it was trained on our population, should work better. And then I end up having to, take a step back, and I feel like I'm on the back foot at that point, trying to educate them about the difference between just, an AI algorithm, a model versus kind of an end-to-end solution that's well integrated and provides value to whether it's a radiologist or a neurologist or a cardiologist or someone else. Can you tell me from your perspective, it sounds like you've gone through that learning curve as well. Tell me a little bit from your perspective, what the difference is between an algorithm and a model and a true solution.
Sure, excellent. That's a great question, and actually a question that we hear from many leading academic health systems, and not only academic health systems at this point in time. AI development is happening in many different provider settings. So the first, an algorithm at the end of the day, what it does is you feed it the raw data. In the case of imaging, an exam, for example. And then the output depends what the algorithm does, right? But it could be a measurement, a detection, etc. The difference between that and a solution that can actually work in a complex environment, like let's take Emory in your case, is huge. It's huge. And that's basically kind of the first 3-4 years of our journey, right? We had an algorithm. Could it have been better at the initial point in time? Yes. But retraining it and improving it and giving it more data and identifying what are its pitfalls and how to identify specific cases that can help it learn better in those specific types of artifacts or specific types of, in our case, hemorrhages, etc. That's just a small part of the challenge, as you referred to it, right? The next step is turning it into a solution. Now, what is a solution, right? So first of all, if we're talking about live settings, we need to get the raw data somehow. And there are many different ways to do it. You can have a PACS forwarded to you. You can get the cases from the modality or multiple modalities, or a VNA or a modality router. It could be a hybrid. You might want to connect your ER scanners directly to the AI server to skip any delays between the modality and the PACS. And then your outpatient and inpatient, which probably aren't as urgent and you can afford to wait another minute or so, those you might want to forward from from whatever system is relevant for your institution. So the first part is having a server that somehow receives the images from the various systems and both creating it in a way that it knows what it's looking for, knows how long it should wait or not wait. By the way, here's another anecdotal little challenge, but something to keep in mind. I'm just giving various examples to show how complex it is. Sometimes there's kind of post-processing and reconstructions and all that. Do you wait for those or not? If you know that your algorithm is better on thin slices than thick slices or a specific type of reconstruction, but it can still work on the other type of series, what do you do? Do you wait? And if you wait, what happens if it never comes? How long do you wait, right? Sometimes the technologist won't do it despite you anticipating it. And do you act differently when it's an acute case versus a non-acute case? Maybe with the acute one, you don't want to wait as fast. You might risk a bit of accuracy, but at least you'll be on time because the radiologist is anyways going to read that case in say 10 minutes, so you can't wait too long. So these are just examples of that one specific junction between the raw data and your AI server. Now, you got the exam. Say you decided that you have everything you need. Now you should, if it's on premise, all right, you run it on premise. If it's on the cloud, you probably want to de-identify it. Most providers won't let you send that PHI up to the cloud. When you process it, what happens if during that time you get other exams coming in? Because large health systems, they could acquire cases almost in parallel, especially across different locations. Do you do it sequential, one by one? Can you run them in parallel? If you do it on premise, it's going to be complex to run them in parallel because you'd need the provider to create a server farm of GPUs. At this point in time, we oftentimes have exams where we have 3 or 4 algorithms running on the same exam. Now imagine another exam and another exam. And what are you going to ask the IT to buy a bunch of GPUs, and can you continue upgrading and maintaining and all that? That's going to be, and it's going to continue growing. It's not going to end. So that's going to be quite complex. So that's, for example, why we chose the cloud approach. And in the cloud, we run instances in parallel, so we can continue processing more and more exams and more algorithms at the same time. Now, there's the transfer of that up to the cloud, or if it's on premise to your specific computing source. Things can break, delays can happen. How do you deal with that? How do you say you did that, you got the results back, now you need to distribute them according to the workflow? Is it to the work list, to the RIS, to the PACS, to a mobile app, to the EMR? Creating all those interfaces. And when someone turns something off, or when something doesn't work, or there's so many, or if your server has downtime, even if it's not you as the AI vendor's fault, so many things can go wrong. And that's where you also need what we call AI operations. So as part of what we do, we take the true SaaS model, which means it's not like we sell a platform and then leave it or charge maintenance fees or something like that. We treat it as a service. So what that means is we monitor ourselves on everything, meaning like, are we processing all the exams we should? Do we see a drift in results? Are there any delays? Are we seeing that the system isn't installed on some workstations and were there cases reported, but the user never got our results? How do I identify all that proactively? Because the IT and the health system, they're not working for us, right? They have a million systems to support. So we need to ensure that we're providing the maximum value. And I just gave those examples as pieces of the solution that are more than an algorithm. And I think maybe Dr. Safdar, to zoom out even further. So that's kind of one part of the answer that, if I were in your shoes, I would try to articulate in terms of the difference, but also, do we have the right people to do all of this, right? Because the nature of the people developing the model is very different than the nature of the people that need to develop the kind of the engineering parts that I just described right now. And does it make sense for a health system to use its IT and engineering team on all of these components that, in a sense, you're kind of reinventing the wheel because vendors like us are doing that anyways. So that's where Aidoc, with specific luminary partners who have that appetite, we've kind of collaborated on more than just our own models. I'm not sure if the audience here has read any of our recent PRs. We've onboarded also specific what we view as best of breed AI models that we have not developed by other companies in the industry, in order to enable any health system that's already using us, that already has the robust backend to leverage it for additional models and not have to do the whole process again over and over again, excuse me. And specifically with certain academic hospitals, we've also worked with them on incorporating their own algorithms that they developed into their workflow. A lot of it is because we have synergies, and a lot of what we've done is already relevant to their model. But it's important to note that that's not a piece of cake either. Like, every model has its unique parameters, unique types of imaging. There's some specific work needed for almost any model, even if it's in the type of exam that we process anyways for a different model.
Yeah, and that's interesting. I mean, what you just said, and you mentioned, so from my perspective, and look, it's no secret, I'm working with you and your company, and we're trying to figure out what our next steps are in our relationship. But one of the things that we're very careful of as an institution is we've got to pick our partners very carefully, because I don't have the bandwidth, and I will lose credibility, frankly, if I try to bring in 5, 6, 7 partners to provide AI services. And you have made there's been a lot of noise this year regarding partnerships, kind of platform enhancements that you mentioned. Can you tell me more about that approach and your partnerships, maybe with, Subtle Medical, Icometrics, River Rain, et cetera, and how that could benefit a place like mine where, frankly, Dr. Gachoya mentioned earlier, we're struggling just with our EMR transition, our PACS transition to keep up with everything.
Yep. So I think we were fortunate enough in the past 5 years from an AI vendor's perspective, to increase our traction and footprint in the market, at least in relative terms and in AI terms. So because of that, a few things happened. And not just because of that, maybe a few things happened in general. One, we were fortunate to be chosen by various health systems and radiology practices to be their AI partner, or one of their AI partners. Oftentimes, we're usually the first AI partner. And that gave us the opportunity to prove to them that we're a good partner. And by proving to them, of course, that includes kind of the agility and the service, the products themselves, the growth with them, the integrations and all that. And that's one way we have credibility, because when health systems consider us, they, at the end of the day, it's a small community. So they'll talk to their colleagues from elsewhere, and hopefully they'll usually hear good things about us. So that's one part that reduces the risk. The other part is, like you mentioned, right? It'd be difficult to support even the most straightforward IT implementation with an AI vendor. Even the most simple approach is still would require some work, security reviews, legal contracts, etc., spinning up a server, maintaining it. So there is some cost there, not in terms of money necessarily, but resources in general. So an additional reason why I think we're chosen is that our own package is fairly, at least in AI terms, is comprehensive, right? At this point in time, we have seven FDA cleared algorithms, and we have 10 cross-specialty solutions based on those algorithms. And we added to that in the past 9 months or so, additional AI partners as well. So now all of a sudden our potential package, it depends on what's chosen by the health system, is over 15 FDA cleared algorithms. But it's not only about the sheer number, right? Because while there's over 100 AI companies, and like many of them don't have FDA clearance, but if you count the number of FDA cleared products in the radiology space, it's several dozen. However, not every use case is top priority for a health system. And even a use case that is chosen, in some situations, there's overlap. Like I mentioned, intracranial hemorrhage, I think that's the most common overlap. I believe there's 6 or 7 vendors in that space. So ideally, a health system would choose the partner that either is objectively the best or the best for them. And because of that, we were very careful with who do we choose to onboard. And we did a lot of diligence, because we really wanted to avoid the whole menu of options where some of the choices might not be good. So we wanted to make sure that every dish that comes out of our kitchen is good, whether we cooked it or somebody else cooked it. And to do that, we did a few things. One, we talked to the market. The names that you mentioned, Dr. Safdar, are, in AI terms, relatively mature companies. So we were already able to speak to some health systems or radiologists that are using these products to hear from them. Is it good, bad? What are the advantages, disadvantages, etc. And we also, behind the scenes, ran together with them, of course, we ran their algorithms on test cases that we provided them, and then had radiologists assess the results from a quantitative perspective. And that enabled us to be comfortable that we're not risking our brand here delivering products that aren't good. So we chose what we think is kind of the all-star team. And we're, at the end of the day, trying to simplify the decision for leaders like yourself. Now, the last point here is also the fact that you mentioned it yourself, right? You mentioned cardiology, pulmonology, et cetera. At this point in time, we're in the era of enterprise imaging. So yes, probably everybody in this room is a radiologist or in the radiology market, but your peers, other clinicians are also using imaging for various use cases. So part of our strategy, this has happened since the beginning of this year, and it's going to be a part of what we do in the next couple of years, has been to also work in a cross-specialty model. Where what I mean by that is, yes, all these cases end up in the workstation of the radiologist, but in some situations, there are other workflows and other physicians using that imaging. So what we tried to do, or so far I think we're doing it fairly well, is we created interfaces and workflows for non-radiologists as well who use these cases. So for stroke, a mobile app, for PE, a mobile app, but also the communication between the radiologist and the interventional cardiologist or interventional radiologist and critical care physician, because that's oftentimes kind of a multidisciplinary decision. And unlike stroke, most PEs are not super urgent, but you still want to find the specific ones that are, and the team needs to kind of collaborate to understand, what do we do with this patient? Is this advanced therapy or medical treatment? So there's communication issues there, and each physician has a different workflow and interface. The critical care physician might be 24/7 at the hospital. The interventional cardiologist might be at home. Those are just a couple of examples, but basically any sort of fairly acute clinical pathway that involves a broader multidisciplinary team that touches imaging is also relevant for this. So also from that perspective, we try to make the decision easier by not only being a one-stop shop from a radiology perspective, but also in general, one-stop shop from a total enterprise imaging perspective. The last point I'll make on this is that the concept of a platform or a marketplace, we don't use the term marketplace, we don't like that term, but that whatever you call it, right, we didn't invent it. In fact, it's been out there for a few years, and we are a partner or have been a partner on some of these marketplaces. What makes our approach unique is that we went bottom up. So we as an AI company understand the challenges of delivering AI in production across interfaces, across the workflow, with the natural kind of challenges of data drifts and modality changes and enterprise implementations. And because we had to solve it out of necessity for our own algorithms, we now have a lot of key technology pillars to do it for other algorithms as well.
Wow, Tom, a lot to think about there, and I'm still, a lot of the things that you mentioned, I'm still kind of churning in my head. But one of the things that you mentioned, you have 7 FDA cleared products yourselves. I imagine that that's going to increase over time. With partners, you may have about 15 or so. And earlier in the meeting today, there was a, in one of the talks. Actually, there was a tweet that was highlighted where a radiologist was complaining about a certain algorithm or a certain solution, but the complaint was that it didn't do something that it wasn't designed to do, meaning, the radiologist expected it to do something that was never, part of its scope of, of solution, what it was designed to do. And maybe the radiologist needed to be educated a little bit more. But for any given chest CT or head CT or X-ray, whatever it may be, there's not just one diagnosis that's relevant for that patient. There could be several. So how do you all, deal with kind of the unique challenges of running multiple potentially FDA approved algorithms, maybe even from partners that you have on the same exam, in light of what you said earlier, that there's time criticality to this, and depending on the infrastructure, it may, it's complex. And the more I think about it, the more intimidated I'm getting, because it's not only the radiologist, but it's also, like you said, I'm getting emails personally from pulmonologists, neurologists, critical care docs, and they all want the result that's relevant to them right now. It's a complicated matrix.
That's a terrific question that is not asked enough, and I think it's also partially due to the maturity of the market, right? In order to really start thinking about these questions, you need to start rolling up your sleeves and experience AI, because just like how we learned many things by developing as a company, starting with our initial implementations and discovering issues that we weren't able to envision, I think the same thing is true from a user perspective. Once you start using and implementing this type of software, you think about issues that you couldn't imagine in the past. The topic of multiple algorithms, or let's begin with multiple pathologies in a scan, right? Some exams can have dozens of pathologies, especially if you count the incidental ones. And what do you do in that case, right? So I can't even count the number of times a radiologist has asked me, hey, can you guys just solve chest x-ray? Can you just catch everything in a chest x-ray? And I keep going back to our AI team and saying, guys, why don't we do an algorithm that does everything in chest x-ray? Why are we going one pathology at a time? With drains and tubes and pneumothorax and lung lesions. That's kind of been our approach, right? Of taking a pathology and doing it well. And that's more of a technology question. So kind of the short answer to that question that I get from my team is, at the end of the day, a chest x-ray with 40 potential findings is, statistically speaking, right? Even if your algorithm is, say, 98% accurate, it's 98 times 98 times 98, do that 40 times, and that's not going to be very high accuracy. And the radiologist will get a bunch of false positives every time they read that exam, and they're going to turn you off. So our approach has been, let's choose the key findings, focus on them so our accuracy can be, quite good, and choose the ones where there's the best bang for our buck. And what I mean by the best bang for our buck is, anytime you process an exam, you're risking a false positive, as well as, of course, a false negative. But so if I'm introducing false positives into the system, I want them to be worth it. One, I want to make sure my accuracy is good enough so I don't create too many of them. On the other hand, I want to catch the findings that I can actually be valuable for the radiologist, to balance that with the false positives. And also from a medical and pathology perspective, like, when is it worth it, right? And where can I provide the most value to the radiologist or to the other type of clinician, or trigger a workflow based on these findings, et cetera. So that's been our kind of, and this is an ongoing debate we continue, and something we look into every 6 months or so. Has been kind of the comprehensive versus various findings and turning them together into something comprehensive. The second aspect there is timing of the results, because you could have different neural networks, or they might run different parts of the exam, and you could have results at different moments in time. So do you wait to give the radiologist the comprehensive experience of having all the results in front of him the second, your last one comes in? Or do you start trickling it down? And as I mentioned, we already run 3-4 algorithms on the same exam. So that's a question we ask ourselves, like, we've had to solve for. And the way we've done so is based on, one, anticipating when the radiologist will read the case, because if he or she will read it in 3 hours, and I can take my time. And if it's something that might be read soon, differentiating between acute positive findings and non-acute positive findings, and accordingly deciding whether to wait more or not. So if I detect an LVO in a CTA, I won't necessarily wait for my brain aneurysm. But if I am detecting something that is a little less acute, like a bone lesion or a lung nodule, then I can wait for other pathologies, because one, usually the case won't be read super fast. And even if it will, I can then create a different, more QA workflow, and let the radiologist, and not disturb the radiologist, because that has a price as well, right? So that's been our approach there. Now, the last point is, you're right, there's a difference between algorithms we develop versus third-party algorithms, whether they're introduced by us or by the health system choosing other AI companies. When it's our own algorithms, we develop them the same way. We control the workflow, we can control their timing, so we can mitigate these potential risks. Also, usually they won't contradict each other, because think about it, a lot of these pathologies are related one to the other. So if I have a mass effect algorithm and an ICH algorithm and a skull fracture algorithm, you can create ridiculous situations where they almost contradict each other, or a hemorrhage measurement algorithm that measures a hemorrhage, that the detection algorithm says there's no hemorrhage. So if it's all from the one shop, then you control it better and it doesn't happen really. If it's from multiple shops, that's where we do the if there are multiple shops, but through our platform, that's where we do the workflow orchestration. And that's where we classify the different algorithms as acute, not acute, anticipate, and do kind of what we do for our own algorithms. If it's not connected to us whatsoever, that's a problem. And that's one of the potential risks and things for health systems to think about, especially from an informatics perspective. How do you solve that? And we're already seeing it, for example, with the stroke apps, like Rapid and Viz and others. They search for ICH, at least some of them, in CTAs for stroke in the non-contrast series, and that can contradict an additional algorithm. And some of them, they don't have an interface with the radiologist, so they might be telling the neurologist or the neurosurgeon one thing, and the radiologist might not get the results, or might get it as a secondary series in their PACS that isn't automatically hung and might not look at it or miss it or whatever. So that can create confusion as well. So that's why we focus a lot, like our core strategy is enterprise imaging starting with the radiologist. It doesn't mean that it has to end with the radiologist, but it's the radiologist is our quarterback, because at the end of the day, every one of these cases has to receive a diagnosis from the radiologist, and they're kind of I always think about it like the Minority Report movie, for those that have seen it, with Tom Cruise, where he has a bunch of like predictions by different technologies, and he's the one running the show and putting all these pieces together. So that's kind of how I imagine it. And this risk or problem is only going to get bigger.
Yeah, Tom, I always thought if I were played in a movie, it would be Tom Cruise that would have to be cast for my role. But you mentioned an interesting thing, so there's, these multiple algorithms. For you, it's, I think it's LVO, PE, there's intracranial hemorrhage, C-spine, free air,
Nice.
and rib fractures. I may have missed one. And
that was impressive. You got 6 out of 7.
And, to the radiologist or the patient, the value is clear. For a busy radiologist, when they've got a stack or a list that's 30 deep at any given time, and the ED is waiting for their read because they've got to keep, their turnaround times low for patient care, the value is clear. And likewise for the pulmonologist, critical care doc, et cetera. But, the physicians in general aren't the ones who get to decide, who have the final say about whether we can bring in a solution like yours. It's really on them, on the administrators, often on the radiologists or the other docs, to prove what the value, what the ROI is going to be to the system. And you mentioned, stroke protocols, for example, and there's been a lot of talk even during this meeting earlier today about reimbursements and various schemes like NTAP for that. What is the value? What do you say when you're working with someone and they're struggling to get the approvals from the big wigs in their system, right? And everybody knows what I'm talking about, right? No decision is made purely based on clinical value. There's a whole slew of considerations. So what is the value or ROI of AI solutions like yours to health systems and those that represent the interests of those systems and leadership?
That's a good question, and something that we are asked more and more as the market matures, and honestly as our price point increases as well. So let's answer it in a more general perspective, because there's different AI products for different use cases. The first question is, who receives most of the value other than the patient from a specific AI product? And that could be the radiologist, or it can be one of the customers of the radiologist, right? One of the clinicians, or it could be the hospital in general and not any one specific clinician. So the first question is, what's the value? If your focus is, for example, to help the radiologist reduce some mundane activities, reduce burnout and improve read time, then that's more of a radiology play. And that would probably be more difficult to have a non-radiology budget fund this, for example. So then in that situation, your business case is towards the radiologist. However, most AI use cases today are while the radiologists are the users and receive some of the value, a lot of the value is to the hospital or to other clinicians or to both. And in that case, we find ourselves in an interesting situation, and it really depends on the health system and how they budget for systems like ours. But there are situations where radiology is the one paying for it, or IT, but the value is, for example, to the hospital in terms of length of stay or DRGs, and that doesn't directly correlate back to the radiology budget. So oftentimes we'll find radiology departments either going to a more general IT, like CIO type budget, or a C-suite budget, or special funding, given the fact that a lot of the value here is to the health system bottom line one way or another. And the types of financial use cases that would be relevant for that are, for example, ER throughput or inpatient length of stay, right? And why does that happen? Oh, actually, I'll get to that in a couple minutes. In addition, it could be liabilities and quality, and creating streamlined workflows for multidisciplinary teams, for example. Or revenue opportunities for the hospital and or specific clinicians or specific surgeons, right? Imagine if we can identify X more brain aneurysms that could then lead to intervention in a timely manner. Obviously, that's good for the patient. That's our ultimate kind of compass, but also financially speaking, it would be relevant to the hospital and those surgeons from a revenue perspective. And that's where kind of it's a mutual challenge, it's a joint challenge to understand what is the relevant purchase process for a specific health system. And anytime the ROI affects other service lines or other parts of the organization, is there something different that needs to be done? And there's not kind of one size fits all process that we've seen. It will really depend on the health system and their purchase process for a system like ours, and what sort of approvals they need and funding sources, et cetera. So we try to be collaborative there with providing the right information, sharing some tips and tricks from other health systems that have been through the same challenges. But at the end of the day, if the premise is that this is a product that is valuable for the patient, valuable for the health system from an overall financial perspective, and the users actually want to use it and see value and wouldn't turn it off, then that's the ultimate win-win. And we just need, because it's multiple stakeholders and the budgets can be in different places, it is a challenging situation. That's why you felt it, Dr. Safdar, and we try to do our best to help with that challenge. And I think that's one of the reasons why AI is being adopted gradually. And for example, why, honestly, from an Emory perspective, right? Aidoc and you, we've been speaking for over 2 years, so it's partially because of those challenges.
Yeah, well, I'm hopeful we can resolve those sooner rather than later, Tom. Tell me, it's a rapidly changing field, and you kind of have a unique perspective to how AI is changing and how your company is going to respond to those changes, anticipate those changes, and stay ahead of them. What does your company look like 2 to 3 years from today, or for that matter, 5 to 7 years? I would venture even 10 years, although now we're getting out on a limb, but as far out as you would feel comfortable predicting. Yep.
So I'll answer in 2 dimensions. The first is, what are the types of functions that the AI is doing? Today, we have mostly detection and a little bit of measurement in terms of what the AI does is detect something or measure something. I think the next level of AI products do a few of those steps together. And the challenge, like take nodules, right? Detect, measure, compare, show change, etc. The challenge with doing that is the same statistical challenge I mentioned earlier with chest X-ray, right? It's 98 times 98 times 98 times 98, and everything's dependent, because we wouldn't want to create a workflow where the radiologist clicks, shows us the detection, and then we measure, because we feel like that's not very seamless. So we want everything to be done automatically in advance. So there's that element. So combining these functions together, there's also prediction. So everything I mentioned so far are things the radiologist does to a certain degree, right? Predicting is where AI can do things that humans can't do, where we just take so much data, combine it together, and do what today is impossible. And we're starting to do that, especially in protocols that weren't made for a specific type of finding. So that's our kind of level 1 of predictions. Obviously, this isn't yet FDA cleared, and also it's going to be a different pathway. But I think that's in a few years products of that nature. And the last point is the whole cross-specialty enterprise imaging. Like our goal is to be that comprehensive suite for the different types of users, different clinicians, but for everybody to have the ultimate, the ideal interface and workflow and no silos. So connecting everybody together according to their native environment. For the diagnostic radiologist, a computer; for others, their EMR and or app.
Well, great. Tom, we are, I believe, at time. This has been interesting. I have more questions I wish I could ask you, so I'm going to schedule time with you personally and then share it by social media if that's okay. But thank you so much for your time, for your insight. A lot that we can all learn from your experience with various centers, and I look forward to continuing the conversation with you.
Excellent. Thank you very much, Dr. Safdar. Great questions today, and thanks everybody for attending.
Thank you all.
Thank you.